the attractive truth about magnetism. Get it? Magnets attract each other, and the facts in here are really true. Think we're just horsing around? Gallop through this book to find out. By Jennifer Swanson. Magnets. Magnets use a force called magnetism. This invisible force pulls or pushes things. Magnets are all around. This is a magnet. Magnets are in a TV. Magnets are in a computer. A computer. Magnets are in your classroom. The magnet are the letters, and they stay up on the board because they're magnets. Push and pull. Magnets use an invisible force that pushes and pulls things. I command you, paper, to stay on the fridge so all can admire my amazing artistic talent. Ooh, this superpower thing has gone too far. The girl pretends she has magnetic powers. The magnet holds the drawing on the refrigerator. The magnet holds the drawing on the refrigerator. Magnetic fields. A magnet has a magnetic field. The magnetic field is the area around the magnet. A magnetic field. The magnetic field can attract. The magnetic field can repel. Magnets attract or repel metals. Attract means it pulls the metals towards the magnetic field. Repel means it's going to push it away from that magnetic field. A giant magnet. The Earth has metal at the center. Oh, so when I look at this picture, I see the Earth, and at the center of the Earth is metal. This is some example of metal. The metal causes the Earth to have a magnetic field. The Earth is one giant magnet. The blue lines do not stand for football plays. They stand for the Earth's magnetic field. Polar opposites. That has nothing to do with polar bears. Polar opposites. Opposite. On the other side. South, north. The opposite of south is north. A magnet has two parts, a north pole and a south pole. The north pole and the south pole are on opposite ends of the magnet. Poles that are different attract. North is attracted to south. They're drawn together, they pull together. Poles that are the same repel. When north and north are near each other, they push each other away. Magnetism rule book. Rule number 1, opposite poles always attract. Rule number 2, like poles always repel. Repel means to push away. Attract means to pull together. Size and shape. Magnets are not the same. Some can pick up cars. Wow, this is a strong magnet. Look how strong it is to pick up this car. It's not just the crane, it's the magnet drawn to the metal that's able to lift the car. Some can pick up cars. Some can only pick up small things. This is a weak magnet. It can only pick up some paper clips. Weak. Paper clips. 3 things affect a magnet's strength: size, shape, and material. Size. Size is how small or big something is. Small, small, big, big. Shape. Star, square, triangle, rectangle, oval, circle, heart, diamond. Or material. Size. Big magnets are stronger than small magnets. Big magnet equals strong. Small magnet equals not strong. Shape. Magnetic poles that are close together make a strong magnetic field. Magnetic poles that are far apart make a magnet weak. Bar magnets are weaker than horseshoe magnets. A horseshoe magnet is stronger than a bar magnet because the poles are far apart. See how the north is all the way over here and the south is over here? Because they're so far apart from each other, this is much weaker than seeing the north and the south near each other. So this makes it a lot stronger. Let's look at this picture. Do we think that the north and the south are near each other? Should this be weak or strong? Yeah, it's not strong because the 2 poles are not close to each other. How about this one? Yeah, we can see that the north and the south part of the magnet are all near each other. So this means that this magnet is strong. The Earth is one big bar magnet. North Pole, South Pole. Material. Some materials are naturally magnetic. Magnetite is a natural magnet. Magnetite. A natural magnet will make other metals be magnetic too. A natural magnet is called a permanent magnet. When a metal touches a natural magnet, it will be a magnet too. This is a temporary magnet. No paper clips were harmed in the making of this book either, but we did turn a few into temporary magnets. So this is a temporary magnet. This is a metal that's touching a magnet. So now this metal has become a magnet, but only for a moment. Because if we take the magnet away, these paper clips go back to just being paper clips. This is a permanent magnet because no matter what, it will always be a magnet. Magnets are cool. The uses for magnetism are growing. There are so many ways we can use magnets. Magnetism is used to power a train. A magnetic wire is on the track. Strong magnets are on the bottom of the train. A magnetic wire is on the track, and strong magnets are on the bottom of the train. North, 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 north. So will these attract each other or repel each other? That's right. North next to north will repel. It pushes the train up. The wire uses repelling and attracting to move the train. Like poles repel and push the train forward. Pulls the train forward, south, north. Repels the train, north, north. Propulsion and levitation. Levitation means to float in the air. Propulsion means to push forward. Doctors use magnetism. Doctors use magnetic resonance imagery to make an image. You go into this machine here, and it maps and scans your brain. This is called an MRI. The machine has a magnet. The magnet makes the hydrogen in a body magnetized. The machine takes a picture of the magnetized hydrogen. Magnetism is a powerful force. Magnets help phones to work. Phone. Magnets help cars go. Car. Magnets help computers to work. Computer. Magnetism is a superpower.